Every day begins in silence, before steel meets heat and sparks.
Inside these walls, raw metal is shaped into engineered strength.
For decades, this facility has carried a singular purpose.
It's demanding work, but every plate has meaning.
Here, every movement creates energy. Every spark tells a story.
The process traces its roots to wartime manufacturing halls. Early designs have evolved into precise digital schematics.
Today, every contour of the hull is pre-calculated and simulated.
It begins with raw steel plates, thick and unyielding. Each sheet is selected for uniform density and structural consistency.
The surface carries the marks of its forging, proof of raw strength.
The first transformation begins at the cutting stations. Precision begins with a controlled edge.
A superheated arc traces each line with millimeter accuracy.
Cut sections form the foundation of the hull's armored shell. Next, heavy form presses begin bending the geometry. The armor's angles are shaped under thousands of kilograms of force.
Each contour enhances the hull's structural rigidity.
Freshly shaped armor plates cool slowly, stabilizing their new form. Automated handlers sort each plate by thickness and curvature.
Technicians verify markings that guide the welding process ahead.
Assembly begins as the first plate locks into alignment. Alignment lasers ensure every edge meets exact tolerances. Clamps secure the plates, locking them for the first welds.
A massive jig forms the backbone, holding every plate precisely in place.
This is the moment the hull takes its first breath of heat.
Molten steel flows, binding the segments into a single structure.
Multiple teams advance along the hull, seam by seam.
Each cooling bead becomes a permanent vein of hardened steel. Automation ensures uniformity across critical structural joints.
Side plates are elevated and rotated with precision machinery. Simulations predict stress paths long before metal meets pressure.
Gradually, the hull's sidewalls rise around the central frame.
Overhead welds seal the upper seams, closing the structure.
Sparks scatter across the surface like brief traces of energy.
Grinding refines the welds, ensuring consistent surface quality.
Slowly, a recognizable silhouette emerges from raw components.
Internal ribs reinforce the hull, distributing impact energy outward.
Internal ribs reinforce the hull, distributing impact energy outward.
Inspection teams scan every seam, confirming structural integrity.
Ultrasonic waves travel through the armor, revealing hidden flaws.
Where necessary, technicians mark segments for additional reinforcement. Robotic welders complete fine corrections with absolute accuracy.
Grinding resumes to restore a seamless surface across the hull.
Internal bulkheads are positioned, giving the hull its hidden strength.
Support frames are bolted into place, anchoring the inner structure. One of the thickest plates, the glacis, is carefully guided into position. Its weight anchors the hull, forming a primary defensive angle.
The internal layout balances mass while reinforcing key impact zones.
Welders take position to seal this critical armor junction.
Heat transforms raw metal into a unified protective barrier. Robotic cranes position the upper hull with millimeter precision before final structural joining begins.
The hull halves move together in a slow, deliberate sequence, the moment the vehicle truly takes shape.
Alignment pins lock in, ensuring the massive structure is perfectly oriented before permanent welding.
Welders begin sealing the joint, one continuous seam that determines the hull's strength and integrity.
Molten filler metal flows into the groove, fusing both halves into a single armored shell.
Automated welders maintain uniform heat and travel speed, producing consistent structural seams.
Sensors scan each completed weld, comparing real-time data to engineering tolerances. Technicians analyze weld quality, ensuring structural integrity meets battlefield-grade requirements.
With the main seam complete, the hull now has the rigidity needed to support heavy internal systems.
As more ribs lock into place, the internal structure begins forming its full profile. Bottom plates complete the armored shell around the chassis cavity.
Sparks rain downward, carving fleeting trails of light.
Reinforced bolts contribute additional mechanical security. Digital models mirror the real hull as every component locks into place.
Inspectors verify bracket tolerances to ensure flawless alignment.
Automated torque systems finalize internal fastening with precise force.
The hull settles into the next station, ready for advanced integration.
The hull is rotated to expose new weld zones, enabling crews to reach every structural angle.
Inside, the empty shell waits for the systems that will define its purpose.
Laser grids project reference geometry to check overall interior alignment.
Intersecting beams highlight deviations measured down to fractions of a millimeter.
A major reinforcement plate is lowered into the hull's center section.
Guiding rails help position the panel before the final lock-in. Hydraulic systems press the surface flush, preparing it for welding. High-precision welders follow continuous seams across the reinforcement plate.
Fresh welds radiate heat as the structure begins to cool.
Outside the hull, cranes maneuver the upper frame assembly into position.
Heavy-duty brackets engage as components begin to interlock. Pneumatic tools drive reinforced bolts into the upper frame joints. Automated sprayers deliver a uniform layer across the entire surface.
Protective coatings are applied, shielding raw metal from early corrosion.
Heat lamps accelerate curing, bonding the primer firmly to the hull. Gloss meters verify coating consistency across all treated sections.
The final top panel is lifted for installation, completing the hull enclosure.
Controlled descent ensures perfect alignment before locking mechanisms engage. Vibration dampers are installed to stabilize the hull during operation. Reinforced fasteners secure the entire top assembly into place. As the metal cools, the seam hardens into a unified exterior surface. A robotic welder seals the upper seams with long, uninterrupted passes. With all surfaces sealed, the hull stands as a fully enclosed structure. Ultrasonic systems analyze the hull's exterior for hidden inconsistencies.
Waveform signatures confirm the structural uniformity of the welded shell.
The hull is transferred to a rotation platform for its final evaluation stage.
Rotational scanning allows inspectors to review every angle of the structure.
The completed hull emerges from the assembly line, fully formed, reinforced, and structurally verified.